To complete the square, you need to rewrite your quadratic in a specific format involving squared brackets. I'll show you an example. Let's say we've got the quadratic x squared plus 12x minus 5. The completed square format of that would be x plus 6 squared minus 41. These two versions look very different, but they are in fact equivalent to each other. There are different methods you can use for achieving this, but I'm going to show you my preferred method. It involves just remembering the trick, and then it's pretty quick once you have enough practice with it. So let me show you the trick. So you start with your quadratic, x squared plus 12x minus 5. And the first thing you do is you write down your squared brackets. You then take the number in front of the x, so in this case that's a 12, and you half it. That will give us 6, and that's what goes inside the squared bracket along with your x. You then take away your new number squared, so take away 6 squared, and then add on anything that was already there in the quadratic. So in this case, we're going to take away 5. We can tidy this up, so we can get x plus 6 squared minus 36 minus 5. And then altogether, that gives us x plus 6 squared minus 41. And we're done. With completing the square, you can check your answer by expanding your brackets again and checking that you get the original quadratic. So let's check this one. X plus 6 squared would look like this. Take away 41. So we're going to expand the brackets however you normally do. I use FOIL, so I'm going to go x squared plus 6x plus 6x plus 36, take away 41, and then tidy up. X squared plus 12x, and then 36 take away 41 is minus 5. So it matches the original quadratic, so we know it's good. Now we know the trick, let's practice it and also talk about some applications of completing the square. One application is for solving quadratic equations. Let's say if you can't factorize it or you don't want to use the quadratic formula, you can complete the square instead. Here's an example. By completing the square, solve x squared plus 10x minus 3 is equal to 0. Give your answers in surd form. We start by writing down the quadratic, and then the instructions say we need to complete the square, so let's do that. We write our squared brackets, and then remember we're going to take the number in front of the x, so the 10, and half it. That's what goes inside our squared bracket with the x. We then take away the new number squared, so take away 5 squared, add on anything that was already there, so minus 3, and this is what we get. Let's tidy up. X plus 5 squared minus 25 minus 3 is equal to 0. Tidy up again, and we end up with this. Now, remember, when we're solving equations, our mission is to find out what x is equal to. So from here, the best thing to do is to probably add 28 to both sides of the equation. So we end up with this. And then we want to get rid of those squared brackets. And the way to do that would be to square root both sides. So when we do that, we get x plus 5 equals plus or minus the square root of 28. Remember, whenever you square root something, you've got to consider the positive and the negative square root. This is a surd. Root 28 is a surd, so it can be simplified. And when you simplify that surd, you get root 4 root 7, which simplifies even further to 2 root 7. Almost there now, we just want to get x on its own. So to do that, we can take away 5 from both sides. So we get x equals minus 5 plus or minus 2 root 7. And that actually provides our two answers for x. So one of the answers will be x equals minus 5 plus 2 root 7, and the other one will be x equals minus 5 minus 2 root 7. Both of those are in surd form, so that's our answer. Another application of completing the square is finding the coordinates of turning points of the quadratic, so maximums or minimums. I'll show you how to approach this question and how to get to the answer, and then I'll explain a little bit more about why it works. By completing the square, find the coordinates of the turning point of the curve with equation y equals x squared plus 8x plus 3. So first things first, let's complete the square. We've got y equals and then squared brackets. X goes in there, half of 8 goes in with it, so plus 4. We take away the new number squared, and then we add on whatever was there before, so 3. Tidying up gives us this. Tidying up more gives us this. And that's it, we've completed the square. So you can get the coordinates of the turning point by just looking at your completed square form. In fact, just looking at this, I can say that the turning point is actually -4 minus 13. That's our turning point. The trick is the x coordinate comes from whatever makes this bracket equal to 0. So when you look at x plus 4, the value of x that would make that 0 is in fact -4. And then the y coordinate is a bit nicer. That is just whatever you see on the end. So -13 is there, -13. I mentioned I'd explain a little bit more about why this works. So let's think about this quadratic a little bit more. The turning point in this case is going to be a minimum point. And I know this because the original quadratic is a positive x squared. So in terms of its shape, it's going to be one of these smiley face curves. So the turning point is the one at the bottom, the minimum, and we're saying it's -4, -13. Because it's a minimum, this is the smallest value of y. Smallest value of y. There are no other y values on this curve smaller than -13. That's important because if we look at the completed square form again, knowing that we want to make y as small as possible means we want to make this number as small as possible as well. And that's why I was mentioning that you want to make that bracket equal to 0. Smallest square number is 0 squared, which is 0. This happens when x is -4 and y is -13, because y would be 0 take away 13. So what do we do when the number in front of the x squared is not 1? For example, if it's 2 or 3 or something like that. It is a tiny bit harder, but it follows a similar method to what we were doing before. You start with your original quadratic again, and the first thing you want to do is actually factor out the 2. So I'm going to put a 2 there, and I'm going to use big squared brackets. I'm going to factor out the 2 from the 2x squared and from the -12x. I'm going to put x squared minus 6x instead. The plus 23, I'm just going to leave that on the outside for now. I've used square brackets because that's a reminder that inside those, I still want to do the process of completing the square normally. So this is where we just repeat what we were doing before. So we stick our x in, we half the -6 to get -3 in there, and we take away the new number squared. Let's tidy this up. X minus 3 squared minus 9 plus 23. And then we've got to be careful with expanding these brackets. So 2 times x minus 3 squared, we can just write it like that. That's fine. 2 times -9 gives -18. And then we've still got the plus 23 on the end. Finally, we can involve that plus 23 in the last step when we're just tidying it all up. So we can write 2x minus 3 squared and then -18 plus 23 gives 5. So our final answer is that 2 brackets x minus 3 squared plus 5. That is in the correct format if you compare it to the question because we've got integers. A, B, and C are all integers there. Let's do another example of this, but this time add on a part B about finding the turning point. Starting with part A, let's repeat the process we just did. So 3x squared minus 6x plus 6. This time we're going to factor out the 3. So we're going to take the 3 out just from the first 2 terms again, leave the plus 6 on the end. When we take that out, it looks like this. Then we're going to complete the square inside those square brackets. Halving the -2 gives -1. Take away the new number squared plus the 6 on the end. Tidying up. Expanding again. Being careful with this part gives this, and then tidying up again. -3 plus 6 is 3. Part B says, hence or otherwise, write down the coordinates of the turning point of the graph. The good news is this part is no different to what we saw earlier. So you're just going to look for what value of x makes that bracket 0, and that would be 1. And then the y coordinate will just be whatever you see there, 3 in this case. And that's the answer. That's it for now. If you found this video useful, please remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else that you think might find it helpful. Thanks, and see you next time.